Hello everyone. So let's solve today's problem, power of numbers. And in this problem, we have been given a number and its reverse. And all we have to do is to return the number raised to its power of reverse, right? So, and there's a note attached here which says the answer could be very large. So we have to print the result modulo 1e9 plus 7. For example, if n is 2, so for a single digit number, the reverse it's is the number itself. All right. So 2 to the power 2 is 4. And in case of 12, its reverse is 21. So 12 to the power 21 is this value, right? So now let us look at the time constraint. So we have to solve this problem in log and time complexity. And if you use brute force recursion, so what you will be using is you will be calling the recursion like this: 12 multiplied by power of 12 comma 20, right? Which means power of n comma r minus 1, because you have handled the first case, right? But this will not get accepted because you will be using big O and time complexity. Since you will be traversing all over this, all over the n, right? So what else you can do? If you look closely, for example, if the number was 24, so its reverse would have been 42. So what we'll be doing is first calculating the half the result. So if you remember, we learned the property of exponents, like a to the power 4 can be written as a to the power 2 multiplied by a to the power 2. So this was nothing but a to the power 4. So we didn't actually calculated the power till 42. We only calculated till 24 to the power 21 multiplied by 24 to the power 21. We only covered the halfway, and since we had the answer stored, we covered the next halfway from the previous, right? So we'll simply multiply the result again, because we have found out the result. We have found out that it's half of the result, right? So, but if you see, if you implement this logic for r equals to any odd number, for example, r equal 21, if you divide it by 2, you will get 10, because it is integer division. So you will do 12 to the power 10 multiplied by 12 to the power 10, right? So this will give you 12 to the power 20. But what we want is 12 to the power 21. So what we'll do is simply multiply the number n again in order to get the desired result. All right. So now let's implement this approach. So if our n is 0, then we'll return 0, because anything to the power 0 is 0. Now if r is 0, then we return 1. Anything to the power 0 is 1. Anything power 0 is 1. Now let's call the recursion. So long answer equals to power of n comma r divided by 2, and we'll take the mod. Now answer equals to answer multiplied by answer, and we'll take the mod. Now we'll return the answer. So while returning, we'll check the condition if r modulo 2. So if it is 0, then we'll simply return the answer. Otherwise, answer multiplied by n. Alright. So now let us compile. Seems like it's working fine. All right. Thank